Alright, so we're going to look at sampling now. And in this little applet here, I have a sample of 100 people. And the blue are women and the red are men. So basically 55 of them, or 55% of them are female and 45% of them are male. So when I take a sample, if this is my population of all people, I want a population that has that same kind of distribution. Okay? So the challenge is for me when I go and I take a sample, and here we go, we took a sample, we had 1, 2, 3, 4, we had like 5 out of 10 of the people wound up being female. Okay, so the key is when we do sampling is we want to take this population that's here and we want our sample to wind up looking like it over here. And basically in this chapter what we're going to do is we're going to look at techniques to ensure that that happens. Alright, so another way of thinking of sampling is let's say that we have to select people that are from the 4 colored areas shown: the blue area, the red area, the yellow area, and the gray area. So if I was just to let's just say that we're going to do a sample, and I would just say, okay, there's my sample. There's my subset of the population. I'm going to take all blue people. Okay, would you say that that's representative of the population? Well, you'd say no. You would say that you know, that's not representative because it left out all the yellow, blue, and gray. So that's not going to be a good representation. Okay. So let's say that we then went and we did this, and we made a let's say that we're going to just make a little line here, and yeah. So let's see. Yeah, we're going to do this, and we did that, and then we said, oh, okay, let's see, we're going to do yellow, and we're going to just do this, and we're going to get yellow, and then we're going to get gray. Let's say, oh, okay, actually let's leave that yellow, and then we're going to change the second color to gray, and that's going to be our population right there. And then we say, okay, well, there's our sample. Okay, and what will we say? Well, we would say, well, you know, that doesn't look like the population either. Okay, what if I was to then do this, and I say, okay, I'm now going to take this, and I'm going to divide that like that, and I'm going to say, okay, let me get some red in there. There's a little bit of red, and then let's get a little bit of blue in there, and you would say, okay, there's my subset of my population. And you would say, well, everyone's represented, but the issue is that they should be fairly equally represented. And in this case, it looks like you know, they are each 25%. But when I do my sample, 67% of them are yellow and gray, and only 33% of them are red and blue. So that wouldn't work for us either. Okay, so basically, if you think about this in terms of sampling, you want your subset. Let's see. I'm going to do this a little bit different. But there's your red, there's your gray. Let's put our blue in. Blue should be up here. It should be a mini version of what we have in our population. And then I'll put my yellow down here. And I'll say okay. There's yellow. And then we'll put some gray. So that is what my sample should wind up looking like. Okay. It should be a miniature version of what my population looks like. So basically, if you keep that in mind, that's the goal. Okay. We want to take this population that's right here and create a subset that it's never going to be exact, but it should be fairly representative of what that population looks like. And if we can do that, then we've sampled well, and that will lead us to being able to draw inferences about the population. Alright, so we're in sample design now. So suppose we want to know the political affiliation of Norwalk residents. In order to answer this question, I will collect data using a survey. And first thing we have to realize is that when we're doing this type of sampling, if I want to know political affiliation of Norwalk residents, why do I do a sample? Well, the reason I do a sample is I can't possibly reach all Norwalk residents. Okay, it's just not feasible that would happen. So since our population is so large, we would have to take a sample from the population. So to whom would I give the survey? Would I give it to all residents? Well, no. People who are able to vote are 18 or older, so I wouldn't give it to anybody under 18. Then there's people who are over 18 who are not registered voters, so I wouldn't really be interested in their viewpoint since they're not going to vote anyways. So it looks like in this case we would want registered voters who are over 18 years old. How would I select which residents received the survey? This piece right here is basically what this chapter is all about. So we might go to a neighborhood that's near us and say, you know, go and ask people. But just remember, those people in the neighborhood around us are like us. So if you live in one type of neighborhood, you might get people who are very conservative, Republican. And if you live in another type of neighborhood, you get people who are very liberal and Democrat. So that probably wouldn't be the best way to get a reflection of what the political affiliation looks like in Norwalk, since Norwalk is a very diverse community. Okay. So we would want a way in which we could get a reflection from people from all over Norwalk. Alright, so we would want a way that we could reach everyone. Okay, and one of the most important things that we would have to do is we would want some type of randomization. And randomization is going to assure for us, and this is the whole key of this whole chapter, that everyone has a chance to be selected, not just people who are like us. Okay? What questions would I ask? Well, you know, this may sound like a simple question, but if I ask a question when I'm out, I could say, you know, are you a Democrat? And you may say, well, that sounds like a good question. Well, it's actually not. It's actually a question that leads a response to say yes. Or I could ask another question that would lead to the same response, and I would ask a question that would say, you're not a Republican. And I would ask another question like, you're not a Republican, right? And that would lead a response to say yes. Well, then obviously you'd have to be a Democrat or an independent. So in this case, we want our question to not lead a response. So the most neutral question we could ask is, what is your political affiliation? and leave it at that. So when we ask a question, we want to make sure it's neutral and it does not lead a person to respond one way or the other. Should have any concerns about their responses. Okay. Well, there's a couple ways to look at this. If you were surveying older people, a lot of older people do not like to talk about political affiliation, what their viewpoints are. So they may not be willing to share that information with you. Okay. So what could happen is a certain part of our population may be unwilling to participate with us. Okay. Some people may not trust us. You know, they don't know who we are, and we're asking them all these questions that are kind of personal. If they don't know, you know, who we are or what we're doing, they may not be willing to participate. So that could be a problem. Okay. Another issue could be when we do this, if we were to do a survey where we asked people, you know, let's say that we put an ad in the paper and we asked people to respond. And we said, you know, we're setting up this survey, go on this website, it's free, tell us what your political affiliation is. Now that's not a good survey design, but the people who would go on the website and participate are people who feel fairly strongly about their party. So there's a few different issues there that I need to be concerned with in a question like this. So those are some things to keep in mind as we begin this chapter. Alright, so we're designing samples now. So we want to gather information about a lot of people. If the group is small, for example, all students in school, we can study each group member directly. This is called the census. A census is an attempt to reach everybody. Okay, so let's say that on a house day, we go out and we put a census out, and we ask a question about house. You know, do you think the house is a good use of time? And we distribute that to all houses 9 through 12. Okay. Well, we're attempting to reach everybody, but everybody may not be in school that day. So we may, let's say there's 1,700 kids in the school. We may only get 1,600 kids that respond. And there may be 100 kids that are not in school for one reason or another. They're absent, or they're on a field trip or something like that. So a census is an attempt to reach everybody. Okay. If, however, the group is very large, for example, all residents in Norwalk studying each group member is not feasible. So that goes back to our example about political affiliation in Norwalk. We can't reach everyone in Norwalk. It just wouldn't happen. So we got to do a sample. So basically, when groups are large enough, we have the sample. So as an alternative, we can select a smaller group of people who resemble the entire group. Okay, we want this to resemble the entire group. Okay, that's very important. So we want all subgroups to have some kind of proportional representation into our sample. Okay. So the entire group of individuals in Norwalk that we want information about is called the population. The part of the population in the study, okay, is called the sample. Okay. So we get a sample from a population. The list of individuals who actually had a chance to be included is called the sampling frame. The sampling frame differs from the population because the sampling frame represents subjects that are present or on our list to be sampled. Well, what does that mean? Well, if we want to know, basically when we're talking about political affiliation, we're talking about adults in the city of Norwalk. So let's say there are, let's just say, for instance, there's 50,000 adults in the city of Norwalk. Well, not all of them are registered voters. So let's say that 35,000 are registered voters. That's our sampling frame. That's the list we have to choose from. Okay, so even though there's 50,000 adults, they're not all going to be part of the list that we can sample from, our list of registered voters. Alright, so the method we use to select the sample is called the sample design. The design of the sample is very important. If the design is poor, the sample will not accurately represent the population, and that's the key. We need the sample to reflect the population. Okay, and those are some of the things I went over in the beginning of this lecture. It does us no good. I mean, we can go out and sample, but if the sample is not reflective of the population that we're trying to gain information from, then the sample is basically useless. Okay. Alright, so let's talk about type of sample designs. Voluntary response samples. This is where a large group of individuals are invited to respond. So you've probably seen these type of things. You're on the internet and some kind of pop-up pops up and it says, you know, do you think the president's doing a good job, yes or no? Or do you think the governor's doing a good job, yes or no? Okay. So in an example here, we can make an announcement in the Norwalk Hour, right, asking for volunteers to email us. Or could ask volunteers to pass out surveys and have residents return them. Okay. Here's the problem with voluntary response samples. The problem is only people with strong opinions tend to respond to those. So for instance, if right now our president is President Obama, so something pops up and says, you know, do you think Obamacare is successful? Okay. Well, the people who are going to respond to that are people who feel very strongly one way or the other. Like, yeah, I think Obamacare is great because everybody's getting health care coverage, so I think that's a great thing. Or you really, really are strongly against it. No, I don't think it's good because you know, it's a drain on our finances, on our budget. It causes the federal deficit to increase. So you have people that are on very strongly kind of polarized on opposite ends of the spectrum, but you have all these people in the middle who are kind of indifferent to it. They don't tend to respond. Okay, so voluntary response sample, only people with strong opinions will tend to respond to them. Okay, so that's not good. It's not a good type of sampling method. Next one's called a convenience sample. We select individuals who are easy to reach. Okay, so an example is if we want to know political affiliation in Norwalk, we survey people that we know. The problem with convenience samples is that they are rarely representative of the population. Okay, in Norwalk we have a very diverse community, so not everyone's like us. Okay, so you have different socioeconomic groups, you have different racial groups. Okay, so all of these different groups have different views and opinions. Okay, and we all think a little bit differently. So basically when we go out and we get a sample, for us to go out and sample the people that we know and like does not necessarily mean that that's going to be a representative sample of the population in the city of Norwalk. So again, a convenience sample is when you just sample people who are conveniently around you. And again, that's not a good sampling technique. So both voluntary response samples and convenience samples results in samples that are not representative of the populations. Okay. These are biased samples. Bias is a bad thing because they favor certain outcomes. Okay. Now let me talk about this term bias. This term bias is used kind of loosely outside of statistics. Okay. Bias is avoidable. Okay. It's not something that has to happen. And it's an error in methodology. And by methodology, I mean it's the way that you set up your sample. It's the method that you use to collect your data. So if your method is not sound, then that leads to bias. But your method doesn't not have to be sound, so it's avoidable. So bias is something that is created in the sample design. It's not something that just happens. Okay. Now, how is bias avoided? It's basically avoided through randomization. Random selection eliminates bias from sample choice. Okay. So basically, if we introduce some kind of randomization where subjects are randomly selected in our sampling technique, then we've now eliminated bias because we've now allowed people from all different types of groups to be included in the sample. Okay. So in these two methods, here's what's happening. In voluntary response samples, people are self-selecting themselves to participate in the sample. Okay, if they want to participate, they can. If they don't want to, they don't have to. So in this case, this is self-selection. In this case over here, convenience sample, okay, we're selecting people who are around us, who are convenient. Okay, so we're ignoring certain groups. So that introduces bias also. So, okay. So these are statistically sound sampling techniques. Okay. So these are non-biased techniques. Simple random sample is very simple. Each individual is equally likely to be chosen for the sample, and each combination of individuals is equally likely to be chosen. That's the definition. So what do? We simply randomly select however many people from our population to be sampled. So an example is generate a list of all students at Brian McMahon High School. Randomly select a group of students from our list. Okay. In our Norwalk political affiliation problem, get a list of all registered voters. Give everybody a number from 1 to let's see, probably from 1 to 40,000, and then randomly select 500 of them. Okay, and we would just randomly select those 500 numbers and see what their political affiliation is. The problem is this is unrealistic for large populations. So what if we wanted to know what the political affiliation is of everyone in the United States? Well, we'd have to get a list. We'd have to get a list from all 50 states, and then we would have to then put all 50 of those lists together and then randomly select people. It would be very hard to do. So this works well, and it's it's the easiest way to randomize, but it doesn't work well for very large populations. Okay, the second technique is a systematic sample. Select every nth individual to be sampled. However, the first subject must be randomly selected. Okay. So here's an example. Obtain an alphabetized list of all students at Brian McMahon High School. Randomly choose the first person, then choose every fifth person on the list. Okay. In our Norwalk example, what we could do is we could go to, let's say that we go to the 2 Stop and Shops in Norwalk, and then what we would do is we would stand outside and we would randomly select a number from 1 to 10, and then we would select every 10th person there for like an hour that walked out, and we would simply ask them, what is your political affiliation? And in doing that, we should, people from all walks of life tend to go to Stop and Shop, whether they're from affluent areas or not affluent areas, whether whatever their racial profile is. People tend to go to a grocery store. So now you might say, well, over near Brian McMahon, people go to ShopRite. Well, we could put somebody at ShopRite too. So we would have to put we'd have to have 3 different samples going on. So that way we would capture we'd capture most everyone that's going to a grocery store. Okay, but the whole key here is you randomly select the first person and then every nth person after that until you have your sample. Stratified sample, divide the population into homogeneous group. Now homogeneity is sameness, some characteristic of sameness. And then select a random sample from each group. So an example, at Brian McMahon High School, well, how can we put students into homogeneous groups? Well, put them in groups by grade. So let's say that we want a sample at Brian McMahon High School, but we want equal representation from 9th, 10th, 11th, and 12th grade. Well, if we do a simple random sample, it doesn't guarantee that. Let's say that we were doing 100 students. Well, if I randomly select 100 students, there's nothing to say that it's going to come out 25, 25, 25, and 25. Okay, so doing a simple random sample, yes, it does have a random component in it, but it does not guarantee equal representation by grade. Neither does a systematic sample. Okay, if we were to put every student in a list and order the list, give every student a number, randomly select the first number, and then every nth student after that, that doesn't guarantee every student is, from each grade is going to have equal representation. So in stratifying, we do that. So we could then take those 4 different lists, and then we could then randomly select 25 students from each grade. Okay, so we would then have 25 9th, 10th, 11th, and 12th graders, therefore guaranteeing equal representation from each group. So stratifying is about homogeneity, and then the way we do it by McMahon is to do it by grade. Cluster sample is about heterogeneous. Okay, heterogeneous is a mixed group. So think of it this way, the group is already mixed together. So what we could do, the most obvious one here would be to do health classes. Okay, because in health classes students are mixed, so there are 2 sets of health classes. There's the 9th and 10th grade health class and 11th and 12th grade health class. So what we could do is we could just randomly select, let's say there's 25 in each class, so we could randomly select 2 9th and 10th grade health classes and 2 11th and 12th grade health classes, and those classes are already heterogeneously mixed. So we would just go in and survey every student in each one of those classes, and that would give us a pretty good representation of the student body at Brian McMahon High School. Okay, so that's a cluster sample. So that's heterogeneous as opposed to homogeneous and stratified. Multi-stage sampling, that's something you need to be aware of, but that's combining 2 or more sampling methods. We select several departments within the school, math, English, and art. Within each of those departments, select several teachers, choose all students within each class. So you're stratifying and then doing a cluster sample there. Okay, so although random selection eliminates bias from our choice of sample, it does not guarantee that our sample is representative of the population. We expect variation from sample to sample. Okay, so if we were to go and do several samples, we would expect to get slightly different results. Okay, so there are two terms that that you need to be aware of, and this term variation, in statistics we call that sampling error. And we think, oh, error, that's a really bad thing. Well, it's really not. What it really means is it doesn't really mean error at all. It means sampling variation. And what that is that's the natural variation that takes place from sample to sample. So sampling error is unavoidable. Okay, sampling error is unavoidable. You can do if I was to do 100 different samples of political affiliation of residents in the city of Norwalk, I'd probably get 100 slightly different results. Okay, and that's to be expected. Okay, because the sample should look like the population, but it's not going to look exactly like it. That's unrealistic. Now, bias is avoidable. Okay, bias is an error in methodology. So when you say that something is biased, that's bad, and that can be avoidable. Sampling error cannot be avoided. Okay, so you need to be able to delineate between those two concepts. If you create a bad sampling technique, that's going to lead to bias. Okay, by the way, bias cannot be corrected. So we do a voluntary response sample and some people respond, and then we say, oh well, we're going to correct that by now doing a simple random or a systematic sample. No, you can't do that. Once the sample is biased, it's no good. It's got to be thrown out. So the data is no good. Can't correct it. Okay, here we expect this to happen. Okay, and the data is okay. That's fine, even though it's going to be slightly off. We're gonna use some statistical tools that will account for that. Okay, so those are two concepts you really have to keep in mind. And sampling, under coverage. This is when some part of the population is left out. Okay. Now, under coverage is going to happen in a poorly designed sample, and generally any sample that does not is not created through randomization. Okay, so if you do a convenient sample and you conveniently sample people around you, people are going to get left out under coverage. Okay, if we do a voluntary response sample where we ask people to voluntarily respond, it's going to lead to under coverage. Why? Because people with strong opinions are going to apply or reply. People that don't have strong opinions are not going to reply, so they're going to be left out. Okay, well, you say, well, you know, if they don't reply, then they're not relevant. They are relevant. They're part of the population. They need to be represented in your sample. Okay, so basically, if you stick with any of these techniques, these 5 techniques right here, these 4 right here, simple random sample, systematic sample, stratified sample, or cluster sample, they all use some type of randomization. Okay, so you're okay. A multi-stage will too, but we're not really going to delve into the multi-stage. Okay, these are the 4 types of sample techniques that you really need to be aware of. Okay, so these will not lead to undercover. Now, that doesn't mean that even though if we do these correctly, that some part of the population may not be represented adequately. Okay, but we know in these two sampling techniques right here, voluntary response and a convenient sample, they are going to lead to undercoverage. Okay. Okay, non-response bias is when people choose not to respond. Okay, so we ask people a question and they're not comfortable with it, or they don't trust us. Okay, so if we're out asking people and we're standing outside a Stop and Shop or ShopRite and we're asking people what their political affiliation is, you might get some older people who don't like to tell people what their political viewpoints are. So we may ask, what is your political affiliation, very politely, and they may just smile and say, I don't want to talk about that, and walk by. Okay. A good example of this is if we were to go out and ask people their height, weight, and age. Now, most women in their 30s, 40s, or 50s are not going to give you their height, weight, and age. Okay, that's off limits. Okay, so anytime that people choose not to respond due to any reason, that's a non-response bias. Okay. Now, response bias is when people are influenced to respond. Okay, so an example of this is you go out and if you are out asking people what their political affiliation is, and you're wearing an Obama hat. Well, that's going to lead a response. People who are Democrats are going to be very comfortable responding. People who are kind of on the fence may be led to respond a certain way. Okay. A very superficial example could be if I was out wearing glasses. Okay, and I was to ask people, do you trust people who wear glasses? Well, the fact that I'm wearing glasses is going to lead a response. Okay, so anything that influences a response, it could be the presence, your presence, it could be something that you're wearing, it could be your body language, it could be the way that you ask a question. Okay, I could ask a question three ways. I could ask a question, do you support Obamacare? Well, that doesn't lead it one way or the other. But I could ask the question this way. Since President Obama has come in office, the federal deficit has tripled. Do you think that Obamacare was a good idea? Well, that leads the person to say, well, no, because the federal deficit is going to increase because of Obamacare. Okay, so that led a response. Or I could ask it this way. I could say, there are millions of people, and children especially, that do not have health care. Do you think implementing Obamacare was a good idea? Well, that would lead a response to say yes, because all these people don't have health care. So in those last two examples, I've led a response one way or the other, as opposed to me simply asking, do you support Obamacare? So again, anything that leads a response is a response bias. Okay, wording of questions. Poorly worded questions. This is what we were just talking about. Okay, with our Obamacare example. Okay. All right, so this whole thing about bias versus sampling error that I was talking about. So bias is an error in sampling design. Okay, it's avoidable. bias leads to a sample that is not representative. Once a sample is biased, it cannot be corrected. Okay, it's very important you realize that. Okay. Sampling error is the natural variation. So when you think of the word sampling error, just think of it as sampling variation. It's the variation that takes place from sample to sample. It cannot be eliminated, but variation is determined by the size of the sample. Okay, by the size of the sample. Okay, smaller samples have more variation, larger samples have less variation. So let's say that let's just say that in Norwalk, 60% of people are Democrat. Okay, 40% are Republican. Okay. So if I was to do a sample of 100 people, I might get anywhere between let's say 50 and 75 Democrats. Let's say 45 and 75 Democrats. So that would be anywhere between 45 and 75%, even though the true proportion is 60%. Okay. But if I was to do a sample of 10,000 people, I would not get samples that were between 4,500 and 7,500. My samples would be a lot closer to 6,000. I might get variation between, let's say, 5,800 and 6,200. So in the first example, when I was doing samples of 100, I had between 45 out of 100 and 75 out of 100. So between 45% and 75% were Democrat. But when I brought my sample up to 10,000, it went between 58 and 62%. So the variation is going to decrease considerably. Okay, so a sample size should be no more than 10% of the population. This is because subjects are sampled without replacement, and removing more than 10% of the population could significantly impact the characteristic of the population. Every time you sample someone, the rest of the population that's left slightly changes. So as you continue to sample more and more people, think of it like a deck of cards. Okay, well, what's the probability of getting a red card? Well, it's 26 out of 52. Well, if I draw a card and it's red, what's the probability of another red card? Well, it now goes to 25 out of 51. Okay, well, that's close to 50%, but not exactly 50%. So when you sample without replacement, your probabilities now change. So taking this into account, we don't want to sample more than 10% of the population. Okay, it is not the size of the sample that determines its reliability, but the methodology that determines its usefulness. Okay, yes, larger samples have less variation. Okay, large samples have less variation, smaller samples have more variation. That doesn't mean that they're good or bad. It just means that we expect more variation in smaller samples. But it's the methodology that determines its usefulness. To determine the presidential election in the U.S. within 3%, you would only need about, I think it's 1,250 voters. That's nationwide. 1,250 voters nationwide to be within plus or minus 3% of the actual true proportion of people who are going to vote in the presidential election. Okay. If you're to go to an ice cream shop, you only need a small spoon to determine if you like the ice cream. If you ever go to an ice cream shop, they give you a little spoon. You don't need to eat the whole 5-gallon tub, though you may like to. But you only need a small scoop to get a flavor of what that ice cream is going to taste like. Okay, so it's the same thing in sampling. Okay, you don't need the whole 5-gallon tub, and that would be our population. You need a scoop that's representative of that population. And as long as your scoop is representative of that population, then you can infer certain things about that population. Okay. So those are some things to keep in mind as we delve into this.